All right, here we go. So I think we are ready for problem number 7 on practice test 3. Does that match up with your records? These are the graphs. So this is the very end of the no calculator part of the test. So we need to graph these 3 equations. And your test will have 3 graphs to do. And you can probably imagine that one of them will be a sine, one will be a cosine, and one will be a tangent. So here we go. When we graph a sine, hash, 1, 2, 3, 4. Now we got to pay attention to whether this is positive or negative, right? So since it's positive, this is going to be a regular old sine curve, going up, then down, then up again, just like that. So that's the picture of your sine. Now, let's talk about labels. What are these labels going to be? 2 and negative 2. So my amplitude is 2. Now these labels are always supposed to be these, 90, 180, 270, 360. But look what we have. A number. So what does that number do? It divides the period, the horizontal. So dividing by a third is the same as timesing by 3. So this would be 270, 540, 1080. So my period is 1080 degrees, right? Okay, all right, now we have a tangent. Now this one's different. It has asymptote, dot at the origin, right? Now we got to pay attention, just like all these, if we have a positive or a negative out here, because the negative will turn it upside down. We don't. So this is a regular old tangent, which means it goes up, squiggles up. Here it is. There are no labels on the y-axis because the tangent has no amplitude, right? Where are the asymptotes supposed to be for a normal regular tangent? Negative 90 and 90. But again, we stuck a number in there, so that number is going to divide those. So these asymptotes are going to be at negative 45 and 45, which means your period is 90 from here to here. Everybody good? Now we got our cosine. Cosine has the same framework, hash, 1, 2, 3, 4 as the sine. But the cosine does not start at the origin, right? The cosine starts up here, but not this one because we turned it upside down. So it's going to start down here. Up and up and down and down. So we're going to have this shape. What are my y-axis labels here?
1/2 and negative 1/2.
1/2 and negative 1/2. My amplitude is 1/2. Now these labels are supposed to be 90, 180, 270, 360. But they're being divided by 2. So now they're 45, 90, 135, and 180, which means my period is 180 degrees. Is that okay? All right, so well now we gotta get our calculators out, because now we're going to do the calculator problems. Now because I have to have different versions of the test, everything isn't gonna be in exactly the same order for all of you. Some of you will probably have exactly the same order of problems, but everybody's gonna have the same kind of problem to do. So everybody's going to have to do a problem like number 8, where we're converting this decimal, 128.735, and we're gonna convert it into degrees, minutes, and seconds. So we remember how to do that, right? Let's get our calculators out, Max. Yep, we're gonna do everything on our calculator now in this section. So we're going to convert to degrees, minutes, seconds. So anybody remember how to do this? Well, first you have to type the number in, right? So first you got to type the number in exactly what it says right there. And then, yeah, second apps, go down to DMS, and it's 128 degrees, 44 minutes, and 6 seconds. Okay, now, be careful on this next section. This is the only section where we're going to have to, for part of the problems, change to radians. The whole rest of the test, everything on the test is in degrees, except for a couple of problems in this section. So which problems in this section will I be doing in radians? Which problems in this section are going to be radian problems? B, C, and E. Now, how do I know those are going to be radian problems? There's no degree mark. It couldn't be any easier. Do you want to pass, Magnus?
No, I called in.
What do you mean you called in?
My mom called in.
You still need to pass, honey.
Oh.
Yep. You still need to check in at the office. Okay. Now, let's go ahead and do the ones I don't have starred. We're going to save the starred ones. So A says cotangent 311. How do I type that in? 1 divided by tangent 311. So negative, 10,000, negative 0.8693. Now I'm skipping to D. So remember how to type this in, sine 52, second apps degrees, 11, second apps down 1 minutes, 12 alpha plus. Did you get 0.7900?
Yep.
And then we're skipping E going to F. Tangent 153, same thing, second apps degrees, 17 second apps minutes, negative 0.5033. Everybody good? All right, so now we're going to change it to radians so we can do these other ones. So for B, what do we press? Second sine 0.514. And we get 0.5398. For C, be sure that you're using the pi button, so 18 pi divided by 17. Make sure you're using the pi button on that problem. 0.1869. And E, that's the one that, oh lordy, everybody better get that one right. 0.2675. That one's so easy to type in, just cosine 1.3. What do you think, everyone? Are we all good? Now, before I move on, I'm going to go back to mode, and I'm going to change back to degrees. Because what have I said now repeatedly? The whole test is degrees, except for these starred problems. So once I'm done with those starred problems, I want to go back to degrees. And you can tell that the next problem is a degree problem. See, doesn't it have a degree right in it? So you know it's going to be a degree problem, but we're good because we changed our calculator. So what do? We see this picture, what do? Matthew? So we write an equation, and we're going to use sine, cosine, or tangent. And this is sine. So sine 37 equals, Matthew?
Oh, I got 12 sine and 37 equals x, and you just type it in.
So sine 37 equals x over 12.
Yeah.
And then you multiplied both sides by 12. And you typed it in. So 12 sine 37, 7.2218. Okay, everybody keeping up here, okay? Alrighty. Here we go, one more of these. Take a look at it. You're gonna write an equation using sine, cosine, or tangent. What do you think? That's gonna be sine. You're gonna say sine x equals 1819. So you're right. You're gonna have to second sign it. When do we know we need to do this, Matthew?
It's when your sine or little weird things are within x.
Exactly. Yeah, your little weird word things, your trigonometric functions are attached to x. When you're taking the sine of x, the cosine of x, or the tangent of x, you're going to have to use this button to get x. It's the only way to do it. So second sine 18 divided by 19, 71.3283 degrees. Now we're going to draw a course of 204. Remember, when you see that compass right there, you know due north is 0. We only label that way when we see a compass. Now, course of 204. So I'm going to start right here at due north. I'm just going to go around till I get to about 204, which is a little after 180, right?
Yes.
That's it. Done. Problem finished. Full credit, hopefully. Okay, so we need two answers. One of them will be done with the calculator. So decimal means with the calculator. It says right there with the calculator. So let's just type that in and get that decimal answer. Tangent, second cosine, 2/5. Remember, you don't have to enter any parentheses. You just type it in. 2.2913. Now, do you remember how we do this by hand? We draw a triangle. We draw a picture of the parentheses. So I'm going to draw a picture of a triangle where the cosine is 2/5. Is that right? Adjacent over hypotenuse. Now I'll do my Pythagorean theorem carefully to get this side, which is going to be what? Root 21. How did she get root 21? She is right. How did she get that?
5 squared plus x squared equals 2 squared.
2 squared plus
I mean,
x
2
squared
squared
equals
plus
5
x
squared. Yeah, that's the setup. That's the setup. Remember, we always have to equal hypotenuse squared. So now I've drawn a picture of the parentheses. Now I'm going to answer the question. What's the tangent? Root 21 over 2. All right, all that's left are our birds in the top of the trees. Here we go. See what we've got. You know, we always have this picture, so I'll draw a couple of these. Alright, so here we go. Oh, we got our squirrel back in the top of the tree. That's 64.5 feet tall. Guess what that squirrel's doing? He's looking at a nut on the ground. His angle of depression is 27 degrees. Find the distance from the squirrel to the nut. So where are you going to put your X? Hypotenuse. Squirrel, nut. Yeah, please put your X in the picture so that you know what function to use. Ferris says sine. Sine 27 equals 64.5 over X. Opposite over hypotenuse. So X sine 27 equals 64.5. And X equals 64.5 over sine 27. What are my rounding directions? 142.07 feet. Everybody okay? Now we have a pelican on top of a lighthouse. And he spots a crab in the water below. The pelican is 93 feet above sea level. And the pelican is 202 feet from the crab. Hypotenuse. Find the angle of depression. Sine X. Uh-oh, we know what that means, right? Sine X equals 93 over 202. So X is second sine 93 over 202. Everybody good with that? Finding an angle? 27.41 degrees. Okay, now we have our airplane and our airport. Alright, so the airplane is currently 4,500 feet above the ground. The angle of depression is 16.3. How far is the airport from the point on the ground directly beneath the plane? That's here. That's here. How far is the airport from the point on the ground beneath the airplane? That would be this point right here, right? All right, function, Sine, cosine, or tangent? Tangent. So tan 16.3 equals 4,500 over x. Opposite over adjacent. X tan 16.3 equals 4,500. And x will equal 4,500 divided by tan 16.3. Probably going to be a large number. But we're not surprised by that because we are talking about an airplane after all. So 15,388.80 feet. All right, here we go, 2 more. Okay, D, find the length of a shadow if a 19-foot tall flagpole has an angle of elevation of 59 degrees. Okay, wait, find the length of the shadow. So where is the X going to go? Right here, yep. Sine, cosine, or tangent? Tangent. So tan 59 equals 19 over x. X tan 59 equals 19. 19 over tan 59. Now some of you say, Miss Ford, this is getting boring. Well, just enjoy knowing what you're doing. Soon enough, it's going to get harder. 11.42 feet. One last problem. What is the angle of elevation of a pre-cal student looking at the top of a building that is 51 feet tall if he is standing 200 feet from it? Yep, this is 200. If I told you to go stand 200 feet from this building, you would just walk out 200 feet right here. That's perfect. So what's my equation?
Tangent.
Tan x, right? Remember, the angle has to go with the tangent, or sine, or cosine. So tan x equals 51 over 200. How am I going to solve for x? Second tangent, yep. Yep, second tangent. So second tangent, 51 divided by 200, 14.31 degrees is my angle of elevation. Now, we have done 3 practice tests. So day after tomorrow, you're going to take a test. So tell me what problem you think you might miss. Which one?
The exact values.
Um,
Finding the exact values.
Okay, so I think I know what you're talking about. So I'll put a couple up here, and then if I have volunteers, that would be great. If I don't, that's fine too. It is being videoed. But no one ever watches my videos, so you don't need to worry about that.
I do.
So let's find the exact value. Now, this means this will be on the no calculator part of the test. Okay, with no calculator. So there are basically just a couple, 3 different kinds. So we have something like the cosine of 5 pi over 6. Okay, so that's one kind. We have the sine of 3 pi over 2. That's another kind. And then we have the kind that has 2 answers. And the question will say 2 answers. And it looks like this. Now, does anyone feel confident to come up and do any of these? just don't want to be movie stars. Okay. Cosine 5 pi over 6. How do we start?
Pi to 180.
So pi is 180. So 180 divided by 6 is 30 times 5 is 150. So we're going to make this the cosine of 150. And then we're going to draw 150. Now this is not a compass. So my labels are the normal math labels. So 150 is over here, and there's my triangle. Right? Remember, normal math is labeled this way. Now, here's the key. How big is that angle right there? 30. 150 to 180, that's 30. So 1, 2, negative root 3. Even the kids that know how to do everything miss points sometimes because they forget these negatives. Please, please, please don't forget your negatives. All right, I want the cosine. What's the cosine? Adjacent over hypotenuse, which would make it negative root 3 over 2 as the answer. Now, the next problem is really exactly the same, except look what happens here. 180 divided by 2 is 90 times 3 is 270. What makes this problem different?
X, Y, straight.
It actually is on an axis. This is 270 down here. When that happens and you're on an axis, you can't draw the triangle. Instead, you have to use your X, Y, and R. And we know R is 1.
Y is negative 1.
So for this point, it would be 0, negative 1. So X is 0 and Y is negative 1. Then we got to remember that sine is Y over R. So Y over R would be negative 1 over 1, which is negative 1. These are the ones that are sometimes undefined, just because you're sometimes putting 1 over 0 or something, right? And then in that same section, this is the one that has 2 answers. So the first thing you have to do is figure out where the answers are going to be. So what are the thoughts? Exactly. Cosine is associated with x. If cosine is negative, then x has to be negative. So you look at your coordinate axis system and you say to yourself, where is it possible for x to be negative? Where would the x's be negative? Right here and right here, right?
Yep.
Now, for this particular problem, adjacent is negative 2 and the radius, or r, or hypotenuse is 2. So negative 1 over 2. You should recognize then that this side is root 3. Remember, if you're not using a calculator, you're limited. I mean, 30, 60, and 45 is about it. So how big is this angle right here? 60. So is that one. So now, no, we know the cosine. Now we have to find the angle. So the angle, remember, is that one would be 180 minus 60, or 120, you're exactly right. And then this one would be 180 plus 60, which is 240. Okay, so Matthew, in that section that says find the exact value, these are the 3 basic kinds of problems that will be there. Ferris?
Can we do one where, like, it says in which quadrant is C?
So you have to figure out what's positive and what's negative.
Yeah.
So let's suppose we want the secant to be positive and the tangent to be negative. That's not the same problem, is it? Alright, so here we go. We want the secant to be positive, and you've got to recognize greater than 0 means positive, and the tangent is negative. Okay? So it's up to you. You might want to look at setting up your regular coordinate system and looking at the SIGNs. X and Y are both positive, X is positive, Y is negative, and so on. Now I want the secant to be positive. Now remember, R is always positive, so he is not part of these conversations. The only things we're worried about here are X's and Y's. So if I'm talking secant, am I interested in the X, the Y, or both? If I'm doing secant. X. And why am I interested in X? Cosine is X over R, and this is the reciprocal of that. So I need X to be positive. Secant is X. I need X to be positive. Where does that happen? Here and here. Right? Now, see that right there? That says the tangent has to be negative. Now wait a minute. If these are my two options, is anything negative here? So the answer must be quadrant 4. Because if X is positive, I'm here or here. If something, I don't care what it is, if something is negative, I can't be here, so I must be here. By the way, the tangent would be negative here, because tangent is Y over X. And if you put Y over X, you would get a negative number. All right, let's do one more of those pretty fast. And we'll do something else if you have something else. Let's say we want the sine to be negative and the cosine to be negative. Okay, so I'm thinking this means negative. All right, sine negative. Sine is which letter? Y. I'm going to look at Y. Y has to be negative. Y has to be negative. Sine is Y over R. So where is sine negative then? Where's Y negative? Right here and here. Now, cosine also has to be negative. Cosine is which letter? X. So X has to also be negative. If these are your only two options, and X has to be negative, aren't we in quadrant 3? Those are easy problems, but what do you have to remember? Cosine is X over R, sine is Y over R, tangent's Y over X. Mr. Schleibacher.
Can we do a arc length one?
Yep. You have to find the arc length. You've got a circle. The central angle is, let's say, 70 degrees. The radius is 10, and we want to find the arc length. So the picture isn't going to be drawn. It's going to be in words. It's going to say this: you have a circle with a radius of 10, a central angle of 70 degrees. What is the arc length? Immediately something should pop into your head. What is the arc length? Radius times radians. And I already know my radius is 10, but I have no idea what this is, right? And I'm going to write that down on my paper so that I don't forget. That's where I get the answer. Because up here now, I'm going to have to do a little work. What am I going to have to figure out up here? Yeah. So how do I do that? How do I get a degree measure changed into a radian measure? Pi is 180, we know that. So what is 70? Right? So here we go. 180x equals 70 pi, so x equals 70 pi over 180. 7 pi over 18. Am I putting that in the answer blank? No. I'm multiplying that times 10. Radius times radians. So I get, if I multiply straight across, I get 70 pi over 18, which I notice they're both even numbers, so 35 over 9.
Yes.
And that is the answer to the question. Great questions. Who else has something that you think you might miss? Day after tomorrow. Audie.
Find the value of all 6 trig functions.
So given one function, find all of the rest. So the list will be there for you. You'll have to find sine, cosine, tangent, I'll go in order, cosecant, secant, cotangent. I don't know what order they'll be in, no promises there, but you're gonna have a list. And you're gonna know one of them, so maybe it says the cosecant is -5/2. And you will be told that theta is somewhere. So all that will be given. You'll be given one of the functions. One of them will be given to you. And you'll be given something like this. Now, what does this do for me? Why do I have this? Tells me which quadrant. I'm going to draw a triangle like I do all the time. And that tells me which quadrant to draw it in. So, using normal math labels, what quadrant is that? 4. And the cosecant, which by the way is the reciprocal of the sine, right, is -2 over 5. How did I know to put the negative with the 2 and not with the 5? The hypotenuse is never negative. You're never going to put a negative on the hypotenuse, right? Ever. Okay, so what do I do to figure out the rest of it?
21, Pythagorean.
I got to do the Pythagorean theorem. So x squared plus 2 squared equals 5 squared. Remember when you do the Pythagorean theorem, the negative squares out, so it's gone. So that's going to end up being root 21 again. Is it positive root 21? Yep. Look where it's at. It's positive root 21. Sometimes it's negative, so pay attention to that. But this one's positive. So then the cosine, Audie, this is adjacent, this is opposite, this is hypotenuse. So the cosine will be root 21 over 5. The secant will be 5 over root 21, which you have to rationalize. The tangent is -2 over root 21. And the cotangent is -root 21 over 2. Not a bad problem, but a lot to remember. Lots to remember there. All right. Who else has something you think one more time will help you get it right? Hand up, Matthew, or the stretching?
Can we work on some of the word problems?
We can do a word problem, yeah. So let's try a word problem. Let's say now, we're not writing out the whole problem. We know the setup's going to be this, so I'm just going to say sentences and you're going to tell me where to put stuff, okay? So I have a bird sitting on top of a flagpole. Okay? He's looking down at a worm on the ground. So I got a bird on top of the flagpole looking at a worm on the ground. How high is the flagpole if the angle of depression is 18 degrees and the worm is 80 feet from the base of the pole?
Adjacent.
Close line.
Max, that makes sense to you? Okay, this is not cosine. This is tangent. You've got to remember this is opposite, adjacent, and hypotenuse. And if you always draw your triangle that way, which is the way I've been drawing all mine, it will always be opposites over, the opposite's going to be the flagpole, or the tree, or the airplane, or, you know, whatever. Adjacent's the ground, and the hypotenuse is the hypotenuse. So this is going to be a tangent, right, Max? Tangent 18 equals x over 80. So 80 tangent 18. All right, we'll try one more word problem, because you'll have one that's like this. There's an airplane up here in the sky. He is 1,000 feet up in the air. There's a man down here on the ground looking up at the airplane, and the airplane is 2,500 feet away from the man. Find the man's angle of elevation. This is a sine problem. Sine x equals 1,000 over 2,500. To find x, this is one of those where we have the second sign. Let's make sure there's no confusion with anybody. When do we know we're going to need to press that button? When x is the variable. When x is the variable, you are going, or x is always the variable. When x is the angle, when x is the angle, we know we need to use that button, right? So let's type it in and that'll give us the degrees. Okay? All right. You guys are always ahead of the game, so you got a few extra minutes you can spend doing whatever you want.
Let's go.
Really?